Mead is a major source of water and power for millions of people out west, but an ongoing drought has caused the lake to fall to record low levels.
The West, as you know, is in the grip of a mega drought, and Lake Mead in particular, this is near Las Vegas, is showing the dramatic effect of falling water levels.
Deep beneath the picturesque beaches and lush landscapes of Florida, scientists have recently uncovered an alarming geological development. Cracks are forming in the very foundation of the state. This revelation isn't merely academic. It touches on the stability of the land, the safety of its communities, and the unseen forces constantly at work beneath our feet. The discovery came as geologists, while analyzing subterranean data, noticed anomalous seismic patterns and unusual ground deformations that hinted at something far more significant than routine subsidence. What they found was a network of newly forming fissures within Florida's bedrock, signaling that the geology of the state is quite literally cracking open. Before we start, smash the like and subscribe buttons for more updates. Florida has long stood as a geological anomaly. Unlike regions carved by mountain-building collisions or shaped by volcanic activity, Florida's landmass is built atop a vast platform of porous limestone. This carbonate foundation, millions of years old, formed under ancient seas that once covered the area. Over time, as waters receded and sediment accumulated, Florida emerged, flat, fragile, and largely hollow beneath the surface. Its unique geology has always made it prone to sinkholes and underground erosion, but what scientists have now uncovered goes beyond those known threats. These cracks are not mere sinkholes, they represent fractures in the deeper structural bedrock, raising a myriad of new questions and concerns about the state's stability. Using advanced ground-penetrating radar, satellite-based interferometry, and borehole measurements, researchers began mapping the underground structures in key areas across central and southern Florida. What emerged was a troubling picture, lengthy cracks extending in patterns never before observed in the region. These weren't isolated, they were interconnected, stretching for miles in some cases, forming what scientists referred to as stress corridors through the bedrock. These cracks appeared to follow subterranean fault lines that had remained dormant and undetected for centuries, lines that, according to new findings, may now be activating. The presence of these cracks indicates that Florida's geological shelf is under new forms of stress, perhaps due to a combination of natural tectonic shifts and anthropogenic pressures. One of the leading theories suggests that the extraction of groundwater, a common practice across the state, may be exacerbating subterranean weaknesses. As massive volumes of water are pumped out from aquifers beneath the surface, the overlying rock can lose support and begin to settle unevenly. Over decades, this can induce fractures that multiply and expand. Coupled with rising sea levels and increased weight from urban development, the land may be reacting in ways scientists hadn't anticipated. What makes this discovery particularly unnerving is Florida's lack of historical seismic activity. Unlike California or Alaska, where earthquakes are expected, Florida has always been seen as a seismically quiet zone. That perception may now be outdated. These cracks suggest that Florida may not be immune to geodynamic activity after all, only that its expressions are subtler, slower, and perhaps more insidious. This kind of silent deformation might not cause buildings to shake violently overnight, but it could, over time, destabilize foundations, compromise infrastructure, and alter water flows through the subterranean aquifer systems that the state relies upon. In coastal areas like Miami-Dade and Naples, where both sea level rise and subsidence are already evident, the formation of deep geological cracks raises critical concerns. Water from the ocean could exploit these fractures, infiltrating freshwater aquifers and accelerating saltwater intrusion, a process already threatening the state's drinking water supply. If cracks connect aquifers that were once separated by impermeable layers, there's also the risk of contamination spreading unchecked. Subsurface water dynamics, once well modeled and predictable, could become chaotic in regions where the underground structure has been compromised. The implications extend beyond water resources. Florida's infrastructure, its roads, bridges, canals, and buildings, rests on a foundation now shown to be less stable than previously thought. Engineers designing structures in the state have traditionally accounted for soil subsidence and occasional sinkhole activity, but the existence of widespread cracks in the bedrock introduces an entirely new variable. A crack that slowly widens beneath a highway could go undetected until the surface gives way. Similarly, a fracture running beneath an airport runway or a high-rise condominium could, under certain stresses, become a point of sudden failure. One particularly concerning aspect of the discovery is its potential relationship with extreme weather events. Florida is no stranger to hurricanes and tropical storms, and with climate change intensifying these phenomena, rainfall volumes and storm surges have grown more severe. When stormwater floods the landscape, it infiltrates the porous ground quickly, sometimes too quickly. In regions with new geological cracking, this influx of water could act like a wedge, penetrating deep into fractures and forcing them wider. Hydrostatic pressure, introduced rapidly and in large quantities, can destabilize fractured rock systems and lead to sudden surface collapse. This synergy between atmospheric and geological stressors could create a cascading effect where one type of disaster amplifies another. Another emerging concern is whether Florida's cracking geology could act as a trigger mechanism for broader changes across the southeastern United States. Though the region lacks major fault lines like those found in the western U.S., there are ancient buried fault systems beneath the Atlantic coastal plain. These faults have been dormant for millions of years, but new shifts in the Earth's stress regime, such as those revealed by Florida's fractures, could, in theory, awaken them. If Florida's geological platform is adjusting, even slightly, it could have ripple effects across the broader southeastern tectonic structure. Small movements in one area may redistribute stress and cause adjustments elsewhere, leading to a reevaluation of seismic risk across multiple states. The discovery has also drawn attention to the delicate balance between natural and man-made geological pressures. Human activity, from deep well injection and wastewater disposal to limestone mining and construction, has long been known to influence subterranean structures. In Florida, these activities are widespread. Phosphate mining in the central region, for instance, involves the removal of vast quantities of material, leaving behind large voids and altering the stress fields in the rock. While the connection between mining and the new cracks is still under study, the possibility that industrial practices are accelerating or even initiating these geological shifts is under serious review. In the realm of scientific inquiry, discoveries like this often lead to more questions than answers. Researchers are now working to understand the full extent of the cracking, its rate of progression, and its long-term implications. They are deploying more sensitive instruments, drilling additional boreholes, and using satellite imagery to create dynamic models of how the ground is moving. The goal is not only to predict where new cracks may form, but to identify which regions are most vulnerable to secondary effects like sinkholes, aquifer contamination, or infrastructure failure. The psychological impact of the discovery is also significant. Florida's identity is tied closely to its geography, its beaches, wetlands, and tropical climate. The idea that the ground beneath this familiar paradise is fracturing challenges both scientific understanding and public perception. For many residents, the news conjures images of instability and uncertainty. Questions abound. Will homes be safe? Will insurance cover damages from geological shifts? Should new building codes be enacted? The answers are still unfolding, but the questions are becoming more urgent. This geological awakening is not simply a story about rocks and faults. It's a reflection of how interconnected the natural systems of our planet truly are. Florida, with its apparent geological calm, now finds itself at the center of a complex and evolving narrative, one where water, land, climate, and human activity all converge to shape the landscape in unpredictable ways. These cracks are not just physical breaks in stone, they are symbolic rifts in long-held assumptions about the region's stability. As scientists continue to monitor and study the developing situation, there is a growing consensus that Florida may be entering a new geological chapter. The notion that the state's bedrock is static and inert no longer holds. Instead, Florida appears to be part of a living, shifting geological system that is only now revealing its complexities. Understanding these cracks, predicting their future behavior, and adapting to the new reality they bring will require a concerted effort across disciplines. Geologists, engineers, urban planners, and policymakers must collaborate in ways that reflect the seriousness of what has been discovered. What lies beneath Florida has always shaped what lies above. From the underground rivers of the aquifer to the natural arches and caverns carved by millennia of water movement, the subterranean world has been a silent architect of the state's surface. Now, with these newly discovered fractures, that hidden world is speaking louder than ever. It is forcing a reconsideration of what it means to build, live, and plan in a region whose foundation may be more fragile than previously understood. The Earth, even in seemingly quiet places, is in constant motion, and Florida has just become one of its more dynamic examples. The discovery that Florida's geology is cracking open has not only transformed scientific perspectives, but has also compelled a reassessment of environmental processes that had long been considered benign or relatively stable. This new geological phenomenon compels scrutiny into Florida's deep-time past as well as its near-term future, revealing a layer of complexity beneath the surface that challenges current models of earth science and regional development. The event is not isolated. It reflects an intricate interplay of factors, many of which were not previously accounted for when considering Florida's geological character. To understand the broader implications of this cracking event, it's important to delve deeper into the historical formation of the Florida platform. This massive geological formation, extending beneath much of the southeastern United States and into the Gulf of Mexico, was primarily shaped during the Mesozoic and Cenozoic eras. While it has always been known as a carbonate platform, characterized by layers of limestone and dolostone deposited in warm, shallow seas, it was generally thought to be geologically stable. What scientists are now questioning is whether the assumed rigidity of this platform may have masked a slow, creeping instability that has only recently begun to surface due to cumulative stresses. The movement now being observed suggests that the platform might not be as monolithic as once believed. Instead of functioning as a single, unyielding unit, it may be subdivided into smaller, interlocking blocks that are beginning to shift in relation to one another. These subtle block movements, if proven, could point to a much more dynamic system beneath the state, one that has only been exposed because of improved geophysical detection technologies and the accumulation of environmental pressure over time. One of the lesser discussed aspects of Florida's geological cracking involves its relationship with the underlying mantle dynamics. While Florida sits far from the plate boundaries that generate most of the world's tectonic activity, it is still under the influence of deep mantle currents that subtly shape the lithosphere above. Some geophysicists posit that these currents, in conjunction with the weight redistribution caused by melting polar ice caps, could be exerting pressure on the base of the continental crust. As mass from melting glaciers is relocated into the oceans, the entire crust undergoes a process known as glacial isostatic adjustment. Although more pronounced in northern regions, the southern U.S. is not immune. That stress redistribution could be translating into flexural adjustments in Florida's crust, contributing to crack propagation. At the surface level, land use changes are further exacerbating the underground stress landscape. Rapid urbanization in Florida, particularly in cities like Tampa, Orlando, and Miami, has resulted in increased ground load due to concrete infrastructure, roadways, and vertical expansion. While the load of a single building may seem negligible, the cumulative pressure of dense urban centers, combined with water table fluctuation and seasonal variability, introduces complex stress vectors into a bedrock that was never meant to endure such burdens. It's akin to stacking weight on a sponge. Eventually, the stress finds its release point, and in Florida's case, that appears to be manifesting as fractures within the underlying stone. In addition to construction and groundwater extraction, climate variability plays an insidious role. Prolonged drought periods, followed by intense rainfall events, generate a repetitive cycle of contraction and swelling in both soil and bedrock. When the land dries, it contracts and tightens. When inundated, it swells and expands. Over time, this repeated mechanical loading and unloading can act like a natural jackhammer, subtly prying open existing weaknesses and allowing cracks to form. These hydrological pulses become more impactful in regions with highly porous limestone, where water can infiltrate deeply and quickly, causing abrupt changes in subterranean pressure. Beyond Florida's terrestrial systems, the state's marine boundary also factors heavily into this geological narrative. The Floridan Shelf, an expansive submarine terrace extending into the Gulf of Mexico and the Atlantic Ocean, connects intimately with the mainland's structural framework. Changes in ocean temperature and pressure, particularly as sea levels rise, apply different loading conditions to the offshore platform. As the ocean's weight increases, especially near the continental margin, flexure of the crust may occur, subtly bowing parts of the Florida platform downward. These shifts may be imperceptible at the surface, but can produce significant stress gradients that concentrate in the more brittle parts of the crust, facilitating the emergence of fractures inland. Ecologically, the formation of deep-seated cracks poses potential disruption to Florida's unique biomes, especially its vast network of wetlands and subterranean ecosystems. The Everglades, a slow-moving river of grass nourished by freshwater that flows from Lake Okeechobee, depends on consistent aquifer recharge and geological stability. Should new cracks interfere with groundwater routing, entire ecological zones could suffer from either oversaturation or desiccation. Moreover, subterranean species, many of which are endemic and adapted to Florida's specific hydrogeological conditions, could face extinction if their habitats are fractured, drained, or otherwise altered. Further inland, the implications for agriculture are profound. Florida's agricultural industry is deeply reliant on its aquifers for irrigation, especially in central Florida, where crops like citrus, strawberries, and tomatoes are cultivated year-round. If the fractures begin to reroute, block, or contaminate aquifer flows, irrigation networks may face significant disruptions. Farmers could experience decreased yield quality, crop failure, or even the abandonment of fertile lands that have become hydrologically unreliable. The unpredictability introduced by these fractures adds a new layer of volatility to an already climate-sensitive sector. Geologists are also examining whether Florida's unique karst topography is becoming even more unstable due to this cracking phenomenon. Karst terrain, formed by the dissolution of soluble rocks like limestone, creates a subsurface riddled with voids, caverns, and passageways. Under normal conditions, these features evolve over thousands of years. However, the propagation of cracks may intersect existing karst networks in ways that accelerate their collapse. Where two systems overlap, a fracture and a cave system, the ground above may lose its last measure of support. In such regions, sudden ground collapse is not just a possibility, but a looming reality. Another area of research emerging from this event is the influence of fault reactivation. The idea that faults once considered dormant or fossilized could be reawakening in response to new stress conditions is a sobering one. Fault reactivation has been observed in other low-seismicity regions of the world, such as the Midwestern U.S., where hydraulic fracturing and other forms of deep drilling have induced microseismicity. While Florida does not have a fracking industry on the scale of other states, the combined effect of drilling, mining, and subsurface fluid movement could be enough to lubricate old faults and facilitate slip. If such a process is underway, the cracking may not be the end of the story, but the beginning of broader geomechanical changes. Perhaps one of the most underestimated implications is the effect on cultural heritage and historical preservation. Florida is home to centuries-old archaeological sites, Native American mounds, and early colonial settlements, all of which rest upon the state's vulnerable ground. The formation of cracks in or near these areas could lead to irreversible damage. Walls may tilt, foundations may shift, and structures that have stood for generations may be rendered unsafe or even collapse. Once cultural landmarks are lost due to geological disturbance, their historical context cannot be reclaimed, only reconstructed in memory. In terms of public policy, the geological cracking forces a difficult but necessary discussion about future development. Should construction be limited in high-risk zones? Will zoning laws be revised to reflect the new understanding of subsurface instability? What protocols should exist for ongoing geological monitoring, and who should bear the cost? These are questions that cut across scientific, economic, and political domains. The state must now weigh the cost of inaction against the formidable challenge of implementing new regulations in an already densely populated and economically active region. Educational systems may also be affected, particularly in how geology is taught in Florida and similar regions. The traditional narrative of Florida being geologically quiet may be replaced with a more nuanced model that incorporates active monitoring and long-term Earth system thinking. Students and educators alike will need to embrace a shift in understanding. seeing geology not just as static textbook diagrams, but as a dynamic, ever-changing force shaping human experience in real time. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on Florida's geology cracking open? Will it get worse? We want to hear from you. Thank you for watching, and see you next time.